Hello, this is Dr. Rudabon. This is part 3 of chapter 1, and I think I'm going to handle this last part of chapter 1 in a little bit different way because it so perfectly overlaps with a specific lab on the atmospheric layers, which are the troposphere, stratosphere, mesosphere, and thermosphere. Each one of these layers has a specific profile based upon temperature changes and density changes that gives them a unique identity. And what I want to do here is go straight to I want to go straight to I'm going to go fast forward here if I can. And I'm going to go to this slide right here. And what really you'll be doing in the atmospheric layers lab is your goal is to try to understand this red line. This red line really shows you how the temperature changes with altitude. If the line goes back to the left, it gets colder. If it goes straight up and down, that means it's leveling out. And then if it goes back to the right, that means it's warming up. So what this tells you is in the troposphere, as you go up, it cools. Then it levels out. Then it warms up in the stratosphere. Then it levels out. And then it goes back down. It cools off in the mesosphere. And then at the top of the mesosphere, it levels out. And then the temperature starts to go back up. If you'll notice at every height where every top of every layer, it tends to level out, and we call those pauses because the temperature stops moving. And the whole key to understanding the 4 layers of the atmosphere deals with understanding radiation and how different types of radiation are interacting with the atmosphere at different altitudes and layers within the atmosphere. Some layers are absorbers of radiation and some layers are transmitters. Absorbing layers tend to get hotter as you go up, like the stratosphere, and some layers like the mesosphere are transmitters which allow radiation to pass through. To really understand this atmospheric layers lab that you'll be doing, which is one of the themes of chapter 1, you really need to understand some of the resources going back to your course under Module 1 under the readings and assignments. I would strongly recommend you to go down through your Chapter 1 resources, and I would strongly recommend you to watch the video on types of radiation and compare also Earth's radiation versus solar radiation here. These 2 videos would be absolutely important for you to understand. And then maybe the final 2 videos here on the layers of the atmosphere and journey through the atmosphere. These 4 layers would be really insightful for you to understand how different layers of the atmosphere are absorbing or transmitting radiation. And that way, when you go through the exercise, you really do understand, and I'll go back here, the troposphere will have very specific things we associate with why do the temperatures decrease as you go up. Why then at the top of the troposphere do you see the temperature leveling off and then actually the temperature is going up? Well, that's where you're going to have to lock in on the fact that there's a specific variable gas concentrated in the stratosphere called ozone, and the ozone tends to be very attractive of absorbing certain types of radiation from the sun, i.e. ultraviolet. So if you go through those videos, you really will understand that this red line is basically the planet's thermostat. If these lines change in any way, they will affect where we are down at the bottom of the troposphere, and they will ultimately affect what the surface planet's temperature. If you change these red lines and change the way they're moving, you could either bake or freeze the troposphere down in here. And so on some planets like Venus, where it's hundreds of degrees Celsius, whereas you could have planets like Mars, where they're hundreds of degrees below zero. And so this is basically what keeps the Earth in its Goldilocks planet zone. So I'm going to kind of skip over the slides that deal with the specific patterns and tendencies within the troposphere, stratosphere, mesosphere, and thermosphere. But be warned, obviously, that you'll be covering those concepts with content in the Atmospheric Layers Lab. I'm going to skip over the northern lights and the southern lights. I would strongly recommend that you would actually YouTube a video on what are the northern lights and actually try to understand, because this actually foreshadows the Atmospheric Layers Lab, is one of the most visual phenomena that we know indicates how our layers above the Earth, our atmospheric layers, are interacting with the sun's radiation. The aurora borealis and the aurora australis, or the northern or southern lights, and understanding what causes our atmosphere to glow would absolutely be helpful for you to understand how our layers do in fact interact with the sun's radiation penetrating through the atmosphere. So I'm going to skip through here, and this slide here is just a foreshadowing that in fact our atmosphere has changed and evolved over time, and how volcanic activity has actually through outgassing influences the gases that we see today. It discusses how carbon dioxide and oxygen levels in the atmosphere are influenced by the levels of how photosynthesis and the biosphere are controlling two of the key gases that control today's atmosphere. So this is just to kind of foreshadow some of the concepts we've already talked about, that our atmosphere is kind of constantly evolving over time, and it can change its chemistry due to processes occurring on the Earth. Some of the basic concepts about weather. Obviously, we'll be discussing pressure and wind throughout the semester, and we love to use weather symbols and terms to communicate weather data, and we'll talk throughout the semester more about the weather station model and how we basically use certain symbols to indicate wind directions and speeds. We also have symbols to communicate the degree of cloud cover, indicating the chance of rain and storms, and we'll go over and actually have more exercises over these concepts. And we'll clearly be talking a lot about temperature and humidity, and our ability to use weather symbols and understand maps like this will be stuff that we'll do throughout the semester, in particular later. Well, I will expect that you'll be able to look at a map and understand, what are these blue and red lines mean? What do these letters L and H mean, and what does that have to do with the weather? And when you look at these weather station symbols down in here, what do these black dots mean compared to these clear dots, and what does this all mean for understanding how weather is changing over time? Is my chance of rain going up or going down in central Illinois by understanding the data on this map? And as we go throughout the semester, hopefully you'll get an idea of, that if you understand how to read this map, you could predict and forecast future weather conditions. And when you start realizing scientists like Galileo have been creating instruments to study temperature, and Torricelli has been creating instruments to measure air pressure for hundreds of years, many of the tools that we are using today have been around for centuries, and we're still using tools that predate America as a nation. And so the idea of using and collecting data about weather is nothing new. The only difference is now is we have much better tools and technology to how to apply and analyze all this data to make accurate weather forecasts. And we'll learn how the Kelvin scale, the Celsius scale, and the Fahrenheit scale all relate to one another. A great YouTube example would be comparing Kelvin, Celsius, and Fahrenheit scales, and you could see how there's obviously a mathematical formula used to convert Kelvin to Celsius and Celsius to Fahrenheit, and you could see at certain temperatures where they all line up. Most of the known world uses the Celsius scale, because you've got these whole numbers. At 0 degrees Celsius water freezes, and at 100 degrees Celsius water boils, and here is the corresponding numbers in the Kelvin scale. And then you see over here in Fahrenheit, where America uses the Fahrenheit scale, we could see the melting point of ice where water freezes and where water boils, and we actually, you could see there's nice conversion tables that you could see how to convert from one scale to the other. The Kelvin scale is used more specifically, but I tell you, a great video to watch would be what is the difference between temperature versus heat. And if you're wanting to learn about what really drives temperature and what is temperature, is most people use temperature and heat as interchangeable terms. And if you put into YouTube temperature versus heat, you could really watch some great videos to understand how temperature really does not measure heat. It actually is a measure of kinetic energy and how much molecular motion is inside these chambers exciting the molecules in this liquid, either mercury or alcohol, in terms of getting them to rise or to fall. So if you give these molecules more energy, they would push up. If you decrease the amount of kinetic energy they had, they would come down. And so thermometers, either in Kelvin, Celsius, or Fahrenheit, are actually measuring how much kinetic energy and motion molecules has. That doesn't necessarily equate to heat. And if you have the time, you could watch a nice video on that. That's it for Chapter 1. And hopefully if you followed along, it'll help you understand concepts in Chapter 1, but also complete the first lab that you'll be doing called atmospheric layers. I hope this helped, and we'll be on to Chapter 2 shortly.